Okay, so what we're going to do now for this removable discontinuity, this is going to be a continuation of what we had on the previous lesson. So we're going to do more mathematical manipulation to render at least part of the function as being continuous. If it needs to be, if it doesn't, then, or can't, then we need to identify those as well. So again, on page 79 in your book, we're going to take a look at the some odd number problems. We'll start with 33. And that is f of x equals x squared minus 2x plus 1. Well, the nice thing about this, if you were to graph this on the calculator, you would see a nice parabola. You would also, you have to kind of sometimes mistrust your calculator because it deals at a large scale. The points, there's no ability to really go minute unless you hit trace like 1,000 times and you get a pretty good idea. But you can't do that. Sometimes the calculator will just stop at a certain point as well. So instead what we have to do is find little hints or directions that it can give us by looking at the equation itself. And this is one of those. There is no denominator. And in order for this to be discontinuous, it has to have either a denominator that can be equal to 0, which is not the case here, or it has to be conditional depending upon two situations. Neither of which exist here. So all x's are valid. So whatever limit we pick, we know we're going to be able to get. Okay? Number 35. For this one, it's f of x equals x squared minus cosine x. Again, we don't have a denominator, but is there something about this cosine x here that is going to make this possibly have a denominator 0? And the answer to that is no. The denominator is always the hypotenuse. For SOHCAHTOA, cosine is adjacent over hypotenuse, and all your values of cosines are going to be between 0 and 1. So you're not going to have any denominators within this function here, and so this is the same as this. All x's are going to be considered valid for this, so that's good. Number 37. We have your f of x equals x over x squared minus x. Well, now we got a denominator. Now we need to see what values are not possible for this. So we need to factor out this x squared. Well, this is one of those that has a common factor in the two terms, which is x. So this can be x on top. We're going to factor out x out of both these terms, and that leaves us x minus 1. Now, based upon this right here, since we can't have 0 as a denominator, this tells us x cannot equal 0 and x cannot equal 1. So there's going to be 2 points of discontinuity in this, but we can eliminate one of them because the x here will cancel out here, and this will leave us 1 over x minus 1. So that would eliminate then this right here. So this, we have removed one of the issues with the denominator here. So we would have to say then that we got rid of the x, it's not 0. So we cancel this out, and this is now a removable discontinuity. In terms of that 0. Okay, in terms of that 0. Now this is still discontinuous over here, but we have removed one part of it. Number 39, we have f of x equals x over x squared plus 1. Now this is an interesting one because of the denominator. We do have a denominator here, and if it's possible to get 0 for that, then we have to deal with trying to remove something here. But unlike this over here where we could, if we had 0 or 1, we get two options of getting 0. X squared is always a positive number. So we have any positive number added to 1 will never give you 0. All right? So just like for the first two here, all x's are valid. So this is a continuous function. Number 41, f of x equals x plus 2 over x squared minus 3x minus 10. Definitely need to factor this out. X plus 2 over here. This is x plus 2, x minus 5. X plus 2 cancels out. And so, because it's cancelable, we are left with 1 over x minus 5. So this is a removable discontinuity. And the last one, f of x equals the absolute value of x plus 2 over x plus 2. Well, these are not factorable because of that absolute value sign right here. This is going to be discontinuous at x equals negative 2. And there's no way we can counter that with this up here. So this is non-removable. Okay, so that gives you kind of some direction of what to do with these. Go ahead and do these 6 problems right here for practice on that. Good luck.